In this eye-opening video, I'm going to reveal the hidden truth that your doctor may not be telling you about brain inflammation that could be secretly damaging your brain, causing brain fog, fatigue, depression, anxiety, short-term memory loss, and even neurodegeneration. Watch this video till the end because I'm going to unmask the arsonists. Yes, there are more than one that can set your brain on fire, leaving you vulnerable to symptoms all throughout your body. I'm Dr. Peter Khan. I'm a board-certified chiropractic neurologist. Now, brain inflammation is a state where your brain cells are inflamed. Now, this can lead to a whole host of problems, not the least of which includes brain fog, where you feel like you can't think properly. You may have difficulty focusing, feel like you have attention deficit disorder. You may have short-term memory issues, where you walk into a room, you forget why you walk in there in the first place. You may feel like you are forgetful more than before. You may have depression, feel lethargic, feel lack of motivation. You may also have anxiety. You may have decreased brain endurance where you do something that's mentally tasking and you just get fatigued really easily. You may also have word loss where you have the word just at the tip of the tongue, you just can't spit it out. You may also have difficulty with arithmetic. Now, this will be like a new onset, right? If you've always been bad at math, that's different. But if you used to be good at numbers, now you're bad with numbers, that could be a sign that you have brain inflammation. You can also have balance problem and even vertigo. Now, symptoms of brain inflammation can spill into the whole entire body, where you feel achy, stiff, swollen, can even lead to digestive issues due to the gut-brain connection. Now, let me know in the comments if you have any of these symptoms that I just described that could be caused by brain inflammation. Type fog in the comments. You will see that you're not alone. And this is very common, and you will soon see it is also under-recognized. Now, let's first understand how brain cells work. Now, brain cells, or neurons as they're called, are made up of the cell body, they're made of dendrites, and they're made up of axons. Axons are the arms that reach out so that your neurons can touch another neuron so you can transmit message. So messages are transmitted from one neuron to another neuron. Now, if we blow up this area, magnify it, the space between neurons are called synapses. And this is a depiction of a synapse where we have the signal coming in and then the receiving neuron. Now, the synapses transmit electrical messages. So nerve messages are transmitted through these electrical messages. When they reach the axon terminals, it causes these neurochemicals from these vesicles to be released across the synapse, the space between the neurons. And when the chemical reaches the other side, it then creates another chemical signal, and that signal is propagated, kind of like batons being passed in a relay. So one message get to another message. This is how your brain's able to control your finger, tell your finger to contract. Now, the way that neurons work, they don't work individually. They work as groups in regions. So this is a picture of your cerebral cortex or your brain facing this way. This is your frontal lobe, parietal lobe, occipital lobe, temporal lobe, and your spinal cord. So the way neuron works is that they work in networks. For example, the frontal lobe is the part of the brain that controls executive function, help you to think and plan, emotions, and even movement. While the temporal lobe controls other things, such as memory, the smell, sense of hearing, it's transmitted in the temporal lobe. Now, what happens is brain function is really controlled by what's called a frequency of firing. Frequency of firing is the rate at which the neurons can send messages. So neurons send message one at a time, one packet of information at a time. So the faster the rate, faster the frequency of fire, the faster you can send message. And then also neurons, brain function is determined by nerve conduction velocity. That determines the speed at which the signals are getting through from one nerve cell to another. So frequency of firing, the rate of how fast the neurons are firing, and then the nerve conduction, which is the speed at which the signal is transmitted, determines how well your brain is working. In general, faster is better because you have faster transmission. If you have inflammation then, brain inflammation, then what happens is the cell bodies, the neurons themselves can get damaged. The machineries inside the cell, called mitochondria, which produces ATP, can get damaged. So you don't produce enough energy, then your neurons cannot transmit messages effectively, then your mental processing slows down. So people just feel like they're in a fog, they can't retrieve information, it takes forever for them to think of something. That's because literally the neurons can get damaged. Furthermore, Not only inflammation can damage the cell body or the neurons themselves, they can also interfere with synaptic transmission, where this process of transmitting chemicals from one end to another is inhibited or slowed down by inflammation. So both of these issues can cause a decreased frequency of firing or a decreased nerve conduction velocity, which causes your brain just to slow down, and then that's when you experience the depression, the low feeling, the inability to remember because your brain works in networks. Furthermore, this inflammation can actually, if there's enough inflammation in the brain, can damage specific regions in the brain. For example, inflammation is just in the frontal lobe. You may experience symptoms that are very classic and characteristic of frontal lobe dysfunction. That might be trouble with executive function, impulse control, attention deficit hyperactivity disorder, and so forth. If you have inflammation in the parietal lobe, you have trouble with sensing bodily sensation because the parietal lobe controls bodily sensation. So we can actually do a neurological exam in assessment form to identify what particular area of the brain is not working and therefore do very specific therapies to help those areas improve. The point is, your brain can have problems depending on what region is affected that can produce different kinds of symptoms. Sometimes though, you can have the whole entire brain inflamed, then symptoms become very diffused. That's where you get fatigue, you're just tired. That's not one particular lobe that may be indicating just the whole entire brain's not working. Now, inflammation is a process that causes these nerve damage and causes the brain cells to not work properly. You also have neuroplasticity. Neuroplasticity is your ability for your neurons to reach out and make a brand new arm and touch another neuron. Therefore, be able to work around the area of inflammation. So if your inflammation level is greater than your ability to compensate with neuroplasticity, which is the process where your neurons become more efficient and adapt, then what you have is neurodegeneration. Neurodegeneration means that you're losing brain cells faster than you can adapt. And if you lose enough brain cells, then you have these conditions called Alzheimer, dementia, Parkinson, which are very serious, which are late-stage conditions. By the time you get diagnosed with Parkinson, Alzheimer, and different forms of dementia, it's already too late. You already lost a lot of brain cells. So early detection is the key. Now let's talk about what drives or what helps the frequency of firing and the nerve conduction. What helps the brain to function well? Well, all neurons require fuel and activation and having no inflammation. Okay, so fuel for neurons comes in the form of oxygen and glucose. Oxygen comes from the air that you breathe, right? We all know how important oxygen is for our brain. If you drown and you don't have oxygen to your brain for 4 or 5 minutes, your brain is dead and then you're pronounced dead. Glucose comes from the food that you eat. So blood sugar stability is important. Now that's a topic for another video. We'll talk about fuel and activation in a separate video. Activation means you actually got to use your brain. As the old adage goes, you don't use it, you'll lose it. That's very true for neurons. Your brain has to be working, which means that you have to engage it in thought process, do novel things, learning something new, and exercising. Again, we'll talk about those things in a separate video. This particular video will talk about inflammation. So your brain doesn't like inflammation because it can start this process of damaging brain. So let's talk about brain inflammation. When you search online for brain inflammation, you go to WebMD and Mayo Clinic. What do you pull up when you type in brain inflammation? Well, what you pull up is encephalitis. Now, encephalitis is a condition where your brain becomes inflamed, typically due to some type of acute infection. It can be due to autoimmunity or other reasons your brain become inflamed, but usually this is an acute process. And your symptoms can include fever, confusion, memory loss, psychosis, seizure, and usually this process develops very quickly. You can develop encephalitis within days to weeks of an inciting initial trigger. And this is a life-threatening condition. So when you have encephalitis, this is where you need medical treatment. You go to the ER and you get in to see your medical doctor, right? So this is not what we're talking about, okay? Because we're talking about chronic brain inflammation. So what if the brain inflammation is not encephalitis? Because encephalitis is to the extreme. It's the most severe form of brain inflammation. But what if you have brain inflammation that's less than an encephalitis? What if you have brain inflammation that doesn't qualify for you to be hospitalized and doesn't qualify for a drug, but yet it impacts you nonetheless? You feel terrible. You have all these symptoms of brain fog, ADD, forgetfulness, depression, lack of motivation, word loss, anxiety, and brain endurance problems. All these issues, but you don't qualify for a drug. What do you do then? This is where we need to identify the root cause, right? And by the way, sometimes people say, well, I don't have encephalitis, right? This is what your doctor would say. Well, brain inflammation. Do you have encephalitis? You don't have encephalitis. Therefore, you're okay. Go home. Or take this antidepressant. You mustn't depress. It's all in your head. So they give you an antidepressant with a long list of side effects that you see in drug commercial that you tune out. But that's not what we're talking about, right? So Western medicine tend to just dismiss people who complain of these symptoms that can be related to brain inflammation without digging deeper. And the question is then, when is a little bit of brain inflammation okay? Like, who wants brain inflammation, period? I mean, if you're watching this video, you made it this far, that tells me that you're interested in not just protecting your brain against neurodegeneration, you want to optimize it. Right? You want to feel great. You want to be able to live to your potential and do everything that you want to do. And that's all predicated on your brain function, which is your most precious organ. So it behooves us to protect it. And the way you do that is by identifying brain inflammation early before it becomes some kind of serious condition. And you do that by addressing the arsonists. So let's talk about the arsonists. When your brain's inflamed, it's like your house is on fire. If you have a fire in your house, properties and cherished memories are destroyed. And if you don't put the fire out, then the fire spreads, causing even more damage to perhaps a neighbor house, and then the whole entire block goes up in flames. So you got to put out the fire. But if you don't catch the arsonists who's setting the fire, you just keep going from room to room, house to house, putting out fires, but never be able to get it under control. Now, the current medical paradigm primarily addresses the fire after it already has started. In my experience, having worked with over 6,000 clients with brain inflammation, you'll get better results by catching the arsonist in the act and preventing the fire from starting in the first place. So just like Smokey Bear, only you can prevent forest fires. So who are these arsonists? Now, one of the arsonists is leaky gut. Leaky gut is a condition where your intestinal tract becomes inflamed and lead to a double whammy of malabsorption and inflammation. And when you have leaky gut, your body becomes inflamed. Now, people think leaky gut is a gut problem with digestive symptoms like gas and bloating and stomach pain. But that's not true. Leaky gut is actually an inflammatory condition that may have started in the gut but spills into the body. And once it's in the body, these inflammatory cytokines can actually cross the blood-brain barrier and trigger brain inflammation. So as the gut is on fire, the brain is going to be on fire, which is your brain inflammation. Now, dysbiosis is a condition where you have imbalance between the beneficial and the bad bacteria or opportunistic bacteria. And this can cause your intestinal immune function to change in a more inflammatory state and change the type of chemicals your gut bacteria can produce, which further promotes inflammation in the gut. So leaky gut and gut dysbiosis is one of the first things we look at because of the gut-brain connection. The next arsonist is mycotoxins. Mycotoxins are toxins produced by mold. Essentially, mycotoxins are one of the most potent neurotoxins out there. Okay? So if you have mycotoxin exposure, mycotoxin can damage neurons. It can cause reactive oxygen species, which means it's going to cause the neurons to basically oxidize and get inflamed, damage neurons, and also block neurotransmitters from being able to function. So mycotoxin can definitely cause brain inflammation and also cause brain symptoms. So we got to identify whether you have mold exposure and whether you have mycotoxins in your body. Next is infections. Now, infections can include viruses, bacteria, parasites, particularly viruses. Viruses, especially herpes simplex virus, such as Epstein-Barr, herpes simplex 1, 2, 6, and 7. These viruses are very good at crawling up nerves, especially the vagus nerve, get into your brain and can cause inflammation in the brain on a chronic basis. But really, even bacteria can cause problem. This is the reason why some of the encephalitis, the acute medical emergency, can be caused by bacteria issue, virus issue. So besides just the brain itself, can also infect the meninges. Those are called meningitis, just another version of that. So we have infections that can cause problems, so we need to identify these chronic infection patterns. Next, environmental toxins. Things like heavy metals, mercury, and lead are known to cause damage to neurons, can lower IQ, could definitely cause nerve damage. Research even shows that these axons and dendrites, the arms of where the nerves go touch other brain cells, can literally shrink so that the neurons cannot transmit messages because of heavy metal toxicity. But things like glyphosate and organophosphates from pesticides and herbicides are just as bad. They're also neurotoxins. There's research that show that organophosphates and glyphosates can actually cause neurodegenerative disease like Parkinson's and can cause neuropathy. So these toxins are things that we identify and we want to seek to help you to detox it. Next is blood sugar imbalance. Now, as we talked about, brain is very heavily dependent on fuel in the form of glucose for function. Too much fuel, overfueling the brain, can cause issues because when you overfuel the brain, it's going to cause mitochondria within the neurons to start to create more inflammation and reactive oxygen species. Furthermore, when you have high blood sugar, the blood sugars start to glycate, which means they stick together, and that sticky substance from high blood sugar is very damaging and inflammatory to not just the brain cells, but all the different cells in the body, including the eye, the kidney. This is the reason why diabetes can lead to complications such as neuropathy, blindness, kidney failure. So high blood sugar is a problem, but low blood sugar is also a problem. Because your brain is so dependent on glucose, a steady stream of glucose for its function, that when you have low blood sugar episodes, it actually makes your brain crash. This is why you feel hangry. You feel lightheaded, shaky, irritable, forgetful. You just get cranky when you don't have enough blood sugar because your neurons literally are falling apart from not having enough fuel. So we must stabilize blood sugar. Next is decreased vagus nerve function. It's important to know that the vagus nerve is a cranial nerve that comes from the brainstem and it innervates the gut and the peripheral organs, primarily digestive organs. But vagus nerve play a really important role in controlling inflammation. In fact, in the scientific literature, this is called the inflammatory reflex, which means that the vagus nerve actually, when it's firing, can dampen inflammation systemically, can dampen inflammation in the brain as well. So if you have decreased vagus nerve function, you may not be able to dampen systemic inflammation in the liver, spleen, and intestine. And then that inflammation in the body can then spill into the brain, cause brain inflammation. Now, some of the things that we talked about here, like leaky gut, mycotoxins, infections, environmental toxins, blood sugar issue, can all impact the vagus nerve. Vagus nerve can be poisoned by toxin, can be affected by infections, can be poisoned by mycotoxin, can be hampered by blood sugar imbalance. So these things can drive this problem as well. Next is autoimmune. When you have autoimmune disease, your baseline level of inflammation is going to be higher than someone who doesn't have autoimmune disease. And that baseline level of higher inflammation is going to cause inflammation throughout the body, which then can breach the blood-brain barrier and cause brain inflammation as well. And then once you get brain inflammation, one of the problems is that you can have cellular debris. As these neurons get damaged, little bits and pieces of these brain cells are floating around in your brain, and they're specialized immune cells that pick up these debris and can potentially trigger antibody production, which means that you can develop antibody to your own brain tissue, the fragment that's floating around, therefore leading to neuroautoimmunity. And that's not good because once you get neuroautoimmunity, inflammation in the brain inflammation speeds up because now your immune system is constantly attacking your brain tissue. It's always there, so you're constantly getting this inflammation. Next thing here is food sensitivity. There are some foods that are very damaging to the brain. For example, gluten. Gluten is a known cause of neurological issues. In fact, when we talk about gluten sensitivity, gluten is known to cause an autoimmune disease called celiac disease, which is an intestinal villus atrophy of your intestinal lining causing malabsorption. But we know that gluten and celiac disease can create extra-intestinal manifestation. Extra means outside the intestine, which means most of the symptom of gluten is actually not in the intestinal tract, but rather a lot of it is neurological. We know that gluten can attack the cerebellum, cross-react with cerebellum, which is part of it that controls balance and coordination. It's in the back of the brain here. Then that's called gluten ataxia. That's a known mechanism. So we need to watch out for gluten, but other foods like dairy and egg, they can also cross-react with either cerebellum or the brain tissue. So if you have sensitivity to these foods, you need to be aware whether that's causing your brain symptom as well, brain inflammation. Soy and corn, they're very heavily subsidized crop in the United States, so they're sprayed with glyphosate, which we talked about as an environmental toxin, which can cause problems. But then some people are also sensitive to lectins within those grains and beans as well, and that can be a source of problem for people. Next is mast cell activation syndrome. Mast cells are immune cells that produce histamine. Histamine is a chemical that your body uses to help you to trigger allergies to things. Now, allergy is just a natural response for your body to get rid of stuff that you don't want, like dust and pollen. But if you have mast cells that are activated too much and is producing way too much histamine, releasing way too much histamine, that can create allergic symptoms. One of the things that histamine can cause, high histamine, is that it can cause brain inflammation. Because these white blood cells in the brain called the microglial cells, they get triggered by histamine. So when you have high histamine, the microglial cells get activated, which triggers more brain inflammation. So we need to be aware of mast cell activation syndrome and high histamine levels. Next is stress. Stress is not just something that's in your mind. Stress produces stress chemistry. So from something that's in your mind that you're worried about, it literally creates a physiology and a chemistry of stress. Stress hormones, cytokines being released, and the stress chemistry is going to have an impact on your brain. Specifically, when you're stressed, it can actually cause your immune system to get out of balance. You can fight off infection as well, so infection will be more likely to rage on. Stress can also trigger mast cells to produce more histamine. Stress produces cortisol, and high cortisol on a chronic basis is very degrading to neurons, especially in the part of the temporal lobe that controls memory. So stress can also cause brain inflammation. And lastly, poor sleep. If you don't sleep well, either you don't sleep enough because you go to bed too late, or you go to bed on time but you just can't fall asleep or can't stay asleep. There are reasons for that. And the poor sleep is going to cause your brain to not able to clear out amyloid beta plaques through the lymphatic system. So your brain has its own way of cleaning out and take out the junk and the garbage at night so your brain can refresh and recover. And when you don't get good sleep, your brain's more likely to become inflamed. Now, the bottom line is that there are many layers of possible root causes that can be setting your brain on fire. And most of the conventionally trained medical practitioners don't look for these arsonists, allowing the fire to continue to destroy your brain and destroy your health while you wait for a diagnosis. Now, they often blame your fatigue or depression on aging, or they say it's all in your head, or that you just need a prescription for antidepressant with a bunch of side effects. In my experience, this lackadaisical approach is dangerous. Because once you lose your brain cells, you don't get them back. The sooner you start dampening brain inflammation, the better you'll be. This is where a detailed, comprehensive history by someone who's trained in both functional medicine and functional neurology, like myself, and ordering the right lab tests can help uncover where the arsonists are hiding. Then the process of putting out the fire and preventing new ones can begin, and you can finally restore, repair, and heal your brain and get your life back. Now, if you got a lot of value from this video, please hit the like button and share this important information with others. If you have not subscribed to our channel, please subscribe so you get notified when I go live and when we drop new videos. See you in the next video. God bless you.